Good afternoon, everyone. Hope you enjoyed lunch. In the beginning, there was this little airline. It's a couple of guys in a field in Dublin, and they got a plane. This was really early on. In fact, I'm pretty sure these guys were selling tickets before the Wright brothers had launched their plane. They were innovators. They'd been doing this before the Second World War, and they were dreamers. They wanted to get people off the island. If anyone knows the Irish, they love to travel. They love to get out and see the world. They tried boats. That didn't work out so well for them. So they thought planes would be the thing. And then as they started selling tickets, they realized, well, we've got a problem. Selling tickets is hard. Scheduling planes is hard. So they thought, we'll get a computer. And as you all know very well, that means they've got two problems. Now they've got a computer and their ticketing problem. They got one of the very first computers on the island of Ireland, an IBM mainframe to run this. This was 1964, and that computer still runs the airline today, which is very impressive. A lot of value delivered from one computer. Now, go about a decade on, 1970s, oil crisis, things aren't going so well. These innovators decided they were going to rent out some of that mainframe capacity to other airlines. They were doing SaaS before any of us had even thought about cloud, or before I was even born. Again, early innovators. Then, fast forward about another decade. They go from one mainframe to two, they have resiliency, they decide they need to put one outside the airport, one inside the airport. Initially, the mainframe app was just one mainframe, but before the mainframes could do failover, they wrote it themselves into their app. They did dual write, instant failover. They realized it was important that the planes could keep taking off. They could keep selling tickets. So again, doing really cool stuff. They then, of course, started putting in normal, Intel-based computers, building business apps, doing the standard thing we'd all do in these data centers. Then, of course, being the innovative people they are, reasonably early, maybe not as early as some of you, they decided around 2012, 2013, they would get their website. Of course, they're one of the first websites, one of the first airlines to sell tickets on their website. They get that website into the cloud. But they wanted to do the right thing, maybe didn't know how. So they took that same data center model. I've got a data center inside the airport. I've got a data center outside the airport. I'll take AZA from Amazon. I'll take AZB from Amazon. And I'll go GitOps, and I'll start building what I need for the website in there. So at least they got it out of the data centers. They could, in theory, scale more capacity. But no IAC, no auto-scaling, pretty much used Amazon as a data center. And then move things on a little bit from there. The typical corporate things started happening. Outsourcing seemed like a really good idea. So they took all their networking. That went into a company, a silo. They took their AWS production account, not the dev account, the production account. That went into a separate company. There was then the AWS accounts themselves. They didn't go to AWS. They went to the incumbent telco to get. But they didn't deal with the networking. That was someone else. The incumbent telco, they dealt with the direct connect into their data centers. But they couldn't talk to them because it was a separate silo. This our networking company that dealt with the networking. The on-call support wasn't run by the people who run the AWS production account. No, that's a separate contract, a separate company. And then their development teams, well, they had the mainframe development team. They, of course, were off to the side. They were doing great work. They're all alone. They're actually a legitimate silo, I think, that's worth leaving alone. But the rest of their development silos, people writing Java code, microservices, exactly the same thing you all deploy today, they're split into two silos, the ones that do it in the data center and the ones that do it in AWS. So silos everywhere. So I proposed this talk. I started writing it May the 4th. I've got Star Wars playing in the background. A New Hope. This is where I come in. So hi, should probably introduce myself now. I'm Rob Lazzurs from a company called Amok, and we specialize in getting airlines into the cloud. Right, this is what we do. A little bit about myself. So I've been 24 years playing with computers for money, so that's kind of what I do, obviously. I started in ISPs and building early clouds. I did that because they had the biggest, coolest computers. They had the biggest, coolest internet connections, and I just wanted to play with big, cool toys. I then went into UK government, and as a small aside to my talk, if you get the chance in your country to go work for the government and do digital work there, I can't recommend it enough. Do some public service, right? My favorite story from working in GovUK, I was working for the prison service, and we put into a couple of prisons, we gave the prisoners laptops. And we gave them content on those laptops. And I gave them Khan Academy, I gave them Wikipedia for kids. And that's all very boring, right? I solved the security problems of getting a CI/CD pipeline into prisons. The cool thing about that gov work was what came back from the user research. It's something I'll never forget. The user said that the product was called a digital hub. He said, thanks to the digital hub, I learned to read. If you get a chance, do public service. So the last 4 years, I've been in aviation. Quite an interesting time to go into aviation. So I left the UK 2019, end of 2019, and started with this airline. And when I started, well, I went there because of the mainframe, right? The idea of this one computer had been there since 1964 and was still running the airline. I just thought, I've got to see this. I've got to touch this. Right? A computer that's been doing this all this time. I want to play with that. Wasn't so easy to touch, it turned out. But I wanted to see that. And when I went there and I spoke to them, the cool thing about them was all those silos I talked about, they hated them. They wanted rid of them. They knew they'd made a mistake. They were the cool innovators, right? This airline, they are really interesting people. And so they wanted to get rid of it, but they didn't know how. And so that's when I come in. So I said there was no IAC, there was no infrastructure code, there was no Terraform code. So of course we're talking about Terraform. There was, but remember I said the AWS production account was run by a separate company? So there was some Terraform code, but only in the dev account. So imagine you're developing a service, you're going to deploy it in your dev environment, you've got some code to do that, but then when you go to production, you hand that code over to the company that does this, and they read your code and they ClickOps it for you. That's what was happening in this airline. It's very sad, but it is what it is. You know, it was an easy place to improve upon, that's for sure. So we were going to start again, and we started looking at the landscape. Now, about end of 2019, Pulumi was a cool thing. You know, I was on Hacker News a lot. AWS CDK was really cool. You know, it was reasonably new. But the truth was, there's all these technological options. We made a choice, and we made a choice not based on the technology, but on the people. The people we had knew Terraform. Now, we could have went with the AWS CDK. We could have went with Pulumi. But they didn't know that, so there was no point in that. What we did do is we took AWS CDK, and we threw it to the wall. We tried a few isolated things in it to see if it would work with them. It didn't stick. So we went with Terraform. And I think that ended up being a right choice. Let's see. So I think these things are very valuable. And I think the pandemic deprived us of all of this. I think getting together, listening and sharing the experiences, because let's face it, we're not going to talk to each other usually, right? We're from different companies. I listened to a talk earlier today from someone that does medical records. When am I in an airline going to speak to them? I'm not going to hear from their experience. And at previous Hashi days in London, I'd heard from Elsevier, and they'd done some really cool things about having a modules monorepo, and I loved their pattern. And I deployed it in Gov before I got to the airline, worked really well there. And so when starting in this airline, decided to go kind of down the same path. Now, Terragrunt, I hope that some of you have at least heard of this. It's a wrapper around Terraform that makes it really easy to do multiple environments, that makes it very easy to take a module and deploy it into dev, into test, into prod, and to do it over and over again. And I've found that that worked really well as well in my previous place. Oh, excuse me. So decided to do the same thing. And of course, I think when starting anything fresh, you should always look again at best practice. You should always treat it like you're a 5-year-old. Like, I know nothing. Of course, I've got 20-something years of experience at this. But if you just go along with that, you're never going to learn anything. So when deploying this, I looked at the best practice for Terraform as it was at that time. I looked how they laid out the environment repo and pretty much copied that. And this is, I did a checkout for the talk. So this was pretty much the first set of commits that I'd laid out in the repo. Now this was called the infrastructure environment repo. The idea here, so if you see at top level, there's a directory, and that's per the legacy accounts, the accounts that we had inherited from the silos in the previous structures. Then the next level down is environments, and then under that, there's these, if you see UAT, X, and 2, those are just environment separators. There's then deployment. So the first module I'd written was for a REST API gateway for the mobile app. But that's the initial structure of the layout. Now, that's evolved quite significantly since. My colleagues here wouldn't have actually have ever seen this structure. And this was about the end of 2019, we were doing this. Now, Atlantis. So when I was bootstrapping that initial version you just saw there, me sitting there with my workstation running Terraform, Terragrunt, is fine. Right? No one cares. No one has to see my plans. No one has to see my plies. And Terragrunt's managing the state file for me, so I don't need to worry about that. But as soon as that gets to n+1, as soon as you've got the second person, the third person, the fourth person, you need transparency. Right? That's really important. You need to be able to see, because if I wake up at 4 in the morning and something's down, and it's because of a deploy someone else did, I want to be able to see that. The other thing that Atlantis was great for was following the same model, the same Terraform GitOps model, right? And it's very easy for users to use. This is the thing I love about it the most. So we've onboarded hundreds of people now into using Atlantis. And I didn't have to write any docs for that, which is good because I'm terrible. I'm awful at writing documentation, just the worst. But for Atlantis, you don't have to do this because this is our front page. This is the first thing. You open up runatlantis.io, and the very top of the page is step 1 on how to use it. Yeah, you open up a pull request against your code repo. In our case, this infrastructure environment repo I've shown you. When you open up a pull request, it runs Terraform, or as I explain to everyone when I send them to the website, just ignore Terraform, assume it's saying Terragrunt. In our case, it runs Terragrunt plan, and suddenly in your pull request, next to the code change, exactly where it should be, you see what it's going to do. So you see your code change in the diff, and then in the comments section, you get to see exactly what that diff is going to do. And there's an example of the plan. And as you can see, not only does it show you the plan, it shows you the code, what it's going to do, but it also, again, it's self-documenting in the comments. It will tell you what you need to do next. So if you want to apply this, comment in the pull request with Atlantis apply. If you want to run a plan again, then you can run Atlantis plan again. Or if you want to delete the plan, click the link. Now, part of the reason I really liked Atlantis was there was two main options for us at the time. It was going to be Jenkins or this. And what I loved about this is I could isolate it. Now, you've got to think about, to start with, we had 3 accounts. Today, we've got 70. Right? This has full control over all of them. So it's full control over an airline. If someone compromises this, planes don't take off, holidays are canceled, business trips, people don't get to HashiCorp. So having a nice, isolated, separate thing that can do that isn't our Jenkins is kind of cool. So here, step 3, moving on. Someone approves your PR. Now this was a very important piece in our change process. This gave us control to enforce policy. This is what allowed us to take 500 developers, an entire organization from no IAC into IAC and do it well. Because we could have a very small team, not necessarily writing the code, but always approving the changes. Step 4, after the approval, you run Atlantis apply. Step 5, boom. Your apply works perfectly every single time. Never a failure. Obviously, we all know that's not true. One of the things, again, I like about the Atlantis model is the repo where you're making the changes. This is running against your branch, right? It's in your PR. So your main branch isn't polluted with something that didn't work if this apply fails, which it does. You then get to plan again, maybe make more code changes and work on your PR until it works. And only when it works, merge it into your main branch. The great thing about this is then from a disaster recovery perspective, your main branch, in our case of our infrastructure environment repo, is part of our DR process. If Amazon lost all of the instances, lost the entire availability zone, we can at the top level with Terragrunt on our environment repo, run Terragrunt apply all, and we could have our environment, the entire company back up within a number of hours. So going back to the IAC code, right? The last thing I want to do, I'm super lazy. In my 24 years, I think I've got even lazier every single day. I don't want to write code, right? I don't want to write Go code. I don't want to write Python code. I love Copilot. When it comes to IAC, I enforced this at the airline and said, you're going to use public modules. There's great public modules out there. There's someone in the audience who's wrote some of the best, I think. And we use these extensively. We use your modules extensively. We use the Terraform AWS modules collection. It's the top of our list. We have 2 recommendations. One, if you're going to do something in Terraform and AWS, go to Terraform AWS modules. Use that module. It's going to be the best. If that doesn't fit for some reason, if there isn't a module to do what you want, look at another company called Cloud Posse. Now, they're a competing consultancy. I still recommend their work. It's excellent. Go to Cloud Posse. That's our documented policy. Only then, if you can't use a module, if you can't use someone else's code to already do what you need to do because it's probably already written, then consider writing your own module. Then consider writing some code. This made things a lot easier from day one. This got us moving much faster. This is the power of community. So as you saw with the repo there was initial service. So we had senior support to do what we wanted to do, to kill the silos, get rid of the companies in between, not necessarily remove the companies, but certainly remove the barriers between the companies, remove the barriers in the silos. We had support to do that, but there's a difference between having support and a large organization, an airline, canceling support contracts and on-call contracts that in theory keeps their business up and running. We have to prove competency with the internal team. We have to show that this internal team, this small team of innovators, right, because everyone at this airline is, that they could really run production. They could support it, it would stay up, and we wouldn't stop the airplanes taking off. So we did this with 2 initial services. One's the API gateway I showed you. The next one was something called the payment hub, and it is exactly what it sounds like. It's what all the payments go through. It's a tokenization service. So that was the first real service that this airline put into production with Terraform code, right? With Atlantis, with Terragrunt, with the modules that Anton's written. And it worked. Right? The airline was taking payments. The service launched, it auto-scaled, it was able to go into 3 AZs, which was a first. We even used a really cool Lambda called auto-spotting to be able to use spot instances with it. It worked, we proved competency. So then we had that legacy account set up. And as you all know, if you're doing AWS, really what you should do, you shouldn't just go and create 3 accounts that have no association between them and call them things. You should create an AWS landing zone. So one of my colleagues, Will Oldwin, a fantastic chap, knows far more about AWS than I do. He created our landing zone. So he's off to the side. I'm playing around with my Terragrunt, my Atlantis. And he's off to the side creating the landing zone. There was a problem with this, though. So this is 4 years ago, remember. The Terraform AWS provider isn't quite where it is today. And we've got all these systems in the data centers that we don't have control over. So we had no authentication service we could use for AWS. There was no single sign-on for the company. It just didn't exist. And so we decided to use what was called at the time AWS SSO. It's now IAM-IC, which I hate the name of. But there was no Terraform control for this. So it was the one thing, sadly, we had to do the thing we hated. We had to click ops, the centralized authentication model for this landing zone. That was painful. One of the things I really like today, where we are 4 years later, is that the provider is moving so much faster, and all of these things are now in the provider. Now, day one, we're playing with this. We're creating our landing zone. We're doing the first services. part of that production competency thing, right? Being able to take over on call from some random company that wasn't really working with us. We had to do alerting, so that's why OpsGenie is on the screen here. OpsGenie has a Terraform provider. It instantly solidified the approach. Not only could we control AWS with Terraform and Vagrant and Atlantis, we could control OpsGenie. We decided to move away from Nexus and into Artifactory, honestly because they were cheaper per user. But it had a Terraform provider too. And later there was then Azure and GitHub and so on. All controlled by Terraform, all controlled by the one monorepo. So one monorepo for modules, one monorepo for the environment definitions. Yeah, so as I said, I started at the end of 2019. It's really hard to talk about an airline without talking about the glorious pandemic, right? It was pretty serious. I went from this super safe government job. I moved to a whole new country, moved my family. I'm working with an airline, and then suddenly the Taoiseach, it's the head of the Irish government, gets on news and says, by the way, no one's going anywhere, and planes are certainly not taking people to other countries. I'm sitting there thinking, wow, good move, Rob. Excellent. Good job. And my friends in government, they're then working on the pandemic stuff, so they're definitely safe. However, one of the things I learned in government, crisitunity. I love this word, right? Never, ever, ever let a good crisis go to waste, right? There's always something to be done. And so when it came to the pandemic times in the airline, I turned around to them and I said, you are never going to have another chance like this. At least I hope not. You're never going to have another chance like this in the existence of your company. Your planes are on the ground. The rest of the time, an airline's a 24-hour business. Yeah? There's always something up there. There's people that work 24 hours a day making sure that the things up there land successfully. Thankfully, computers are not involved in landing. Those of you that need to take flights, you don't need to worry about that. We can't, cause problems with that. Takeoff's the only problem. So we're crisitunity. Right? We've got this pandemic, the planes are on the ground. Why don't we migrate? Why don't we get all of the stuff that's in those data centers out into the cloud? This is our golden opportunity. Now remember at the start of the talk, I talked to you about that 1964 mainframe. Yeah, there's a cloud for that too. So we were able to migrate everything to the cloud. So thankfully it was accepted as a good idea. And as with all good ideas, this airline's part of a larger group. The larger group had some of the similar thoughts as well. So it turned out the whole group of airlines started doing the same thing. Planes are down, let's shut off the computers and move them. Great idea. However, that mainframe thing, so there is a cloud for it. And for those of you who don't know, it's called IBM Z Cloud, right? But when is a cloud not a cloud? I remember at the start of cloud, there was a lot of talk about this. Should it have an API? Should it have this? NIST made a whole definition of what a cloud is. My definition is really simple. If you can't use Terraform to manage it, it's not a cloud. Right? Now, in this case, so I emailed the team at zCloud. I said, cool, where's your API? You're a cloud, right? I want to be able to spin up LPARs because I want to be able to do Docker containers on my mainframe because you can do that these days. And they said, oh, yeah, sorry. LPARs are virtual machines on mainframe. Sorry, Rob. If you want new LPARs, you need to email this guy in South Africa. Okay. And for about 5 seconds, I thought, you know what? I can write a Terraform provider to do that. Needless to say, because it's not there in the registry, I did not do this, right? I decided against this idea. However, the data center migration had to go on. So we'll skip the mainframe for a bit. Bugzilla, I'm sure you've all heard of this. That mainframe team, they didn't track their bugs in Jira. Jira was something new and fangled. Not interested. They had a Bugzilla instance. And the other team that used this was what's called the GCC. They're the people that keep the airplanes in the air. And they used Bugzilla to talk to the mainframe team and register bugs. What we decided we wanted to do is, again, proving competency. We wanted to find the simplest business app that was important, would get some attention. But you know what? If we messed it up, the planes are still going to take off. And so we found this Bugzilla instance on a server. And if you want to look it up, it was version 4.4. It's that old. It's incredibly old. I think 2013 or something. It was basically installed and never updated. We wanted to move that. And we want to get away from the network. We want to get away from the VPN, because again, that's a separate silo, right? That doesn't like talking to people, and they don't want to do things for you. You don't want to make changes. And so we took this into AWS. We put authentication gateway in front of it. We put AWS backups on it. We put AWS monitoring on it. This was the shiniest Bugzilla instance you've ever seen, especially of 4.4. This became our golden example of how to do an app. Just a single app, not one of our Java microservices, not something part of the website. You've got a business app, follow this example. And this was one of the great things. We were a module to do this, again, using the community modules, but our module used a bunch of community modules to then host Bugzilla. And it worked. Now, of course it did, right? We're just taking something and putting it somewhere else. It was resilient. It could run in any of the 3 AZs. Obviously, I think we put out a single instance. I honestly can't remember. But it worked. It was the perfect example. It became the gold standard module for everything else we did. Now, the network's the thing. As I said, the network, the direct connects, they were provided by one company. They were managed by another, and no one wanted to talk to us. If you're doing a data center migration, if you're getting people out of the cloud, getting people out of the cloud. Whoops, that's future times. If you're getting people into the cloud from their data centers, make sure you can control the network. Yeah, because if you can't do this, you've got problems. If you can't get the data out, and I had similar examples in government, if you can't get the data out, you're not going to be able to migrate to the cloud. If your pipes are too small and you go to start copying data and you take the airline down, which happened, then, because again, the networking silo, they had no monitoring on network. Why would they monitor their capacity? So the network's the thing, right? Pay attention to your network. Going slightly back now to developers and talking about examples. This is the worst name I've ever had for any project ever in my life. But what this is an internal module we made for our developers to use. So whilst on the side we've got a team run by a guy here, Callum, who did the data center migration, we've got a service developer needs, and we created a module, collection of modules for them to do that, right? Simple auto-scaling, blue-green deployments of whatever you want into AWS, and it's this. And the great thing about this is, as a developer, kind of like the demo from this morning, our developers don't have to care about Terraform. They don't have to care about how it works. They feed in some variables to this, and boom, they get a deployment of their app. All auto-scaled, backed, monitored, graphs, all the things you expect. And of course, for that, they need Jenkins. Now, when I started at the airline, they had not one, not two, not three, 4 separate Jenkins instances run by different teams, no configuration as code, no monitoring, no backups, all the terrible things. One of the things we did to get this organization into containerization is we ran Atlantis, we ran Jenkins, we ran Artifactory and containers. We wanted to dog food the container experience. We wanted to teach internal teams how to use containers. Doing that with the public app first is not the right place. That's going to hit your users, the real people who want to get to Disneyland. Doing that with the internal tools first, let the internal people skill up, let the internal innovators skill up on how to do all of that. But what we need to do, so we've got Jenkins, we want to start getting towards continuous delivery for these services. So we've got Atlantis, and you can deploy new versions. But it's PRs, it's a bit manual, it's not happening on, it's not being triggered. So we decided to get a bit more GitOps about it. And so this here is an example of one of our Vagrant definitions. And obviously it's a cut down example of it. But what we decided to do to keep the whole Jenkins configuration GitOps is we started putting our own hints into these files. So all those variables with CI underscore, what those do is build Jenkins jobs for deploying this, deploying updates. So you go from this, Vagrant.htl, which is and this again is a cut down version of it. This is for deploying, obviously, Keycloak. You've got your Vagrant.htl for deploying Keycloak. It then builds into this, which is, again, a sample of ci.yaml. And then that, with some Python magic, builds into this. So you go from, I've got a Vagrant definition for deploying my code, to just with a few extra lines in your file, I've now got Jenkins jobs for deploying updated versions of my apps. No users building jobs, none of that. So anyway, moving swiftly on, because I'm running out of time. The last thing I wanted to talk about was a GitHub migration. So they were on an old Bitbucket server, wanted to get over to GitHub. Again, the power of Terraform, right? We can do all of that via Terraform. 1,200 repos, 400 users. One YAML file. OK, it's a bit big. It's a megabyte, which, I mean, doesn't sound big. But it's 30,000 lines, but that defines all of the repos. The cool thing about this is suddenly we get control of GitHub in the same way we've got control of the rest of the production infrastructure. We suddenly can make sure that our branching policies are in place and so on. And then the last cool tool I wanted to talk about that we deployed, and this I think is the most important one, is infra cost. So you saw that PR process. You get to see what your change is going to do. With infra cost, you get to see how much your change is going to cost. Now that, every developer in this airline, every time they deploy something, they know how much they're charging the airline. Now, of course, it's not their money. They don't necessarily care so much. But we all know, and senior people know, you spend too much money, eventually someone's going to come along and say, well, that work you did, can you refactor it? Can you make it smaller? Can you make it cheaper? And that's boring work. No one wants to do it. We want to work in cool features for users. So infra costs, I cannot recommend it enough. And lastly, where are we going next? Well, I mean, part of the reason we're here. Vault and Consul. So right now we do the configuration stores in AWS parameter store, which has its limitations, as you all already know. And secrets management is very manual. Everything else is automatically deployed. But secrets management, we're putting secrets into AWS ourselves. Now, lessons learned. Enforce rules. So if you're going to do something like this, if you're going to bootstrap an entire organization the size of an airline, you need to have a choke point to start with. If you're going to train 300-400 people on how to use a process like this, you need a place, and we used Atlantis, and pull request approvals, to help train up everyone on best practice. Here's how you write Terraform code well. Here's how you deploy this well. Adapt. So the airline changed quite significantly pretty much after we started, right? 2019 became 2020. We had to adapt the code. We had to adapt our systems. Have good examples. Like I said with the Bugzilla module, it became the golden example of how to do deployments. It's a terrible app, was used by almost no one, but the Terraform code behind it became the golden example of how to get things done. Never say no. That's what this really should say, right? When you're in an organization, you're there to get something done. We're there to get people in airplanes and get them off to Disneyland. You can't just turn around and say, we're not going to do that because I don't like the technological implications. You need to always answer, yes, here's how we're going to do it. Yeah, if you want to enforce a way of writing Terraform code, if you want to enforce a way of managing clouds, don't say, no, you're not doing the thing you've asked me to do. Say, yes, here's how we're going to do it. And then break the rules. I don't want to be the man. Don't follow rules. Like, I know it's the opposite of what I said, but sometimes you're going to have to break the rules as well. You can set the rules, you can write down rules in README, you can enforce them with policy enforcement, you can make Atlantis follow the rules. But make sure you've got break glass, because sometimes at 2 in the morning when the airline's down, you're going to need to break those rules. And that's it. Thanks for listening.